Okay, I want us to go back to the investigation on pages 254 and 255 this weekend, and look at these concepts, deductive and inductive reasoning. Deductive reasoning is based on rules or laws, and inductive reasoning is based on an observed pattern. You may have heard of the fictional detective Sherlock Holmes. His famous line was elementary, my dear Watson. He would see various patterns or bits of evidence and make a conclusion based on this evidence. He was the champion, if you will, of inductive reasoning. Okay, we have a couple of things here that we talk about when we talk about inductive and deductive reasoning. We have a premise or an argument. It's what you're told or shown or what you see. And the conclusion is what you decide after knowing this premise. In deductive reasoning, which is based on a rule or a law, if the argument is solid, then the conclusion is guaranteed. Here would be a premise or an example of that. The measures of three angles in a rectangle are all 90 degrees. That's the premise. That's what we've observed or we've deduced, if you will. Our conclusion is that the measure of the fourth angle is 90 degrees, and this is based on the rule or the law that says that a rectangle has four 90-degree angles in it. In inductive reasoning, which is based on an observed pattern, if the argument is solid, the conclusion is supported but not guaranteed. Here would be a premise. A number pattern begins with 3, 4, 7, 9, 11. Conclusion is the next number will be 13. Well, that next number might be 13, but it might not be 13. It might be some other number. If our premise had said that an arithmetic series begins with the numbers 3, 5, 7, 9, and 11, then the next number would have been 13, and this would have not been inductive reasoning. This would have been deductive reasoning. A conditional statement is a logical statement that can be written in if-then form. A conditional statement has two parts. It has a hypothesis, or the condition. It has a conclusion, or the judgment, what you decide after you've seen or heard the hypothesis. Here's an example. If a driver sees a red light, she should stop. That's based on a law. The law says if the if the light is red, you should stop. Here's another one. If an animal is a cat, then it is a Siamese cat, I suppose. Well, that may not be true. So that would be actually a false statement. Okay, we have a counter example. A statement that shows that a hypothesis is not true. Here would be an example. If the student is a teenager, then he is 14 years old. Here would be a counter example. Bob is 15 years old and is still a teenager. So this statement would be a false statement. Then we look at the investigation on page 5, investigation 5 on page 320. And the title is Using Logical Reasoning. From the investigation that we just talked about, a conditional statement has a hypothesis and a conclusion. Conditional statement can also have a converse, an inverse, and a contrapositive. Well, what are these statements, or what do they consist of? A converse, here would be an example. The original if-then statement said if a figure is a triangle, then it has three sides. The converse of that would say if a figure has three sides, then it is a triangle. So what you do on a converse is you just simply reverse, if you will, the things that are in the then part of the statement. It has three sides, and replace it in here for the triangle. So you just reverse the roles of the parts of the statement here. That's the converse. The inverse The original statement said if a figure is a triangle, then it has three sides. The inverse of that would be if a figure is not a triangle, then it does not have three sides. So in this case, you replace, you insert some words here, a couple of words. Is not a triangle, then it does not have, should be have now, have three sides. So that's the inverse. Well, what is the contrapositive? You turn the if-then statement around and make it not. Kind of like a double negative. The original statement was if a figure is a triangle, then it has three sides. The contrapositive of that, now what is a contrapositive? You turn it around, you put the three sides first, and you make them not. Okay, so the contrapositive of this statement would be if a figure does not have three sides, notice that I put the three sides first and I inserted the word not, then it is not a triangle. Triangle was stated first, and the contrapositive is stated last and has the word not ahead of it. Okay, on page 321, send me answers to A, B, and C. And I'd like for you to notice that when you write these the converse and the inverse of these statements, they may not be true if the original statement is true. But the contrapositive will be true if the statement is true. Hope you have a good weekend.